All right, welcome back. So we are looking at assumption testing, and if you're not sure how I got to this point, you should go back to the previous video. Um, the chi-square tests are non-parametric, so you don't have to worry about having a normal distribution. It doesn't rely on normality to calculate the p-value. You do need two variables that are categorical, and they have to have at least two categories, or else they're not variables. And they need to be independent. The other thing is that you're supposed to have a large enough sample size so that your expected cell count is at least 5. So in this example, I'm going to go ahead. I'm going to unclick column percentages for the time being, and I'm going to go to the expected counts as I showed in the previous video. So you can see here that one of our cells is expected to have less than 5 people. So really for this one, you should instead conduct a Fisher's exact test. And the Fisher's exact, it calculates an exact p-value rather than an estimated p-value. And it's better for when you have smaller samples. Now, typically a small sample is like less than 30, but we have a pretty small sample for having a 2 by 3. And so we can go to this Fisher's exact test and we could look at that p-value. The thing is that it's more conservative, so it's harder to find a statistically significant relationship. But our p-value in our original chi-square was like extremely big, so 0.49. That it doesn't really serve a purpose. So if you fail to reject the null hypothesis, it's extremely unlikely that your Fisher's exact test would be significant. So you can just say this isn't significant. There's no significant difference. There's no significant association between these variables. So in the next video, I'm going to talk about interpreting the results. And then in the APA style, I will talk about how to write about Fisher's exact if you end up using that.